It's been an amazing progression because if you think about the complexity of the energy system we have today and where we are going and where we have been 10 years ago, right? The early issues, and it still exist today. You have a lot of energy companies that have different assets that were manufactured at different times by different manufacturers, wind and solar in particular, the big two. Integrating that into a useful system has been very difficult for operators to achieve. I think you've really bridged that gap now in terms of software, and that had to be a big hill to climb to do that. You want to explain how you accomplish that and how you kind of working that in software?
Yeah, so that you make a very good point over there. So when renewable energy were representing a very small percentage of the global energy production, they were not creating a problem. But as the amount of renewable energy has grown to reach 10%, 20%, 30%, in some countries even 50% or more of the energy being produced, this is also increasing the fluctuation on the grid. So the grid that we had before, which was designed for big monolithic power plants, was not sufficient to handle the fluctuation and the distribution of these renewable energy power plants. So, new technologies had to be invented to put this under control, not just the monitoring, but also the capability to shut down the power plants when a wind farm was producing too much or when a solar power plant was producing too much to avoid fluctuation on the grid. So the software somewhat evolved with these challenges. At the very beginning, we were focusing on gathering the data from the power plants, and the key focus really from the utilities was just to visualize this data. Later on, the challenge came because each of these power plants is typically produced by a different manufacturer. Now you have not only different technology, clearly a wind turbine works in a very different way than a solar inverter and an hydroelectrical power plant or a geothermal power plant. But each of these power plants may actually be manufactured by a different OEM, by a different vendor, by a different original equipment manufacturer. And each of these vendor is actually creating its own way to exchange data and its own way to control the power plant. It's like having a different fleet of vehicles. So you can think of wind, solar, and hydro making a relationship with transportation. You can think of them as airplanes, cars, and maybe trains and ships. Essentially, they're all moving people from one place to the other, but they're doing that in very different ways. So that challenges no one had solved before us. So early 2010, we came out with the first system, which was unifying the monitoring and the control of different renewable energy sources all under one roof, regardless of the energy type, the technology type, the manufacturer, the vendor of that power plant, regardless of the communication protocol, regardless even of things like unit of measurements. Imagine a wind turbine produced in the US will measure the wind speed in feet per second, and one produced in Europe will measure it in meters per second. So, these utilities, these owners of the power plants, as the number of power plants was growing, they really needed to have that unified platform. So that was the first challenge that we addressed.